Let's look at finding the limit as x approaches infinity. There are going to be three different types that we're going to see, right? The end behavior of the function, maybe it goes to negative or positive infinity. Maybe we have a horizontal asymptote and we're approaching some value, or maybe we have a horizontal asymptote where we approach 0. So looking at this first one, I'm looking at the limit of this function as x approaches negative infinity. So when we're looking at end behavior, I want to think about not exact values, like not exactly where it's going, but think in general, right? Where is it approaching? How is this function growing? So when we're looking at how a function is growing, we have to look at what piece is growing the fastest. So in this case, like I don't care about this -4 because a trillion -4 is still really, really, really close to a trillion. Then I don't really care about this plus x because that's just growing too slow. This x to the third is growing way faster. So now we can just look at this leading term and think about what's going to happen to that if I plug in a really, really big negative number, right? So if I were to plug in negative a billion, well, it's going to grow, it's going to get really big, and it's going to stay negative. And as we put larger and larger, or I guess smaller and smaller numbers in, it will continue to go towards negative infinity. So anytime that we have a lot of growth, we might shoot to negative or positive infinity. We just have to look at the degree and see if it's an even or an odd degree, right? Odd degree, the sign's not going to change. An even degree, when you plug in a negative, it becomes positive, right? This is also the case if we had a rational function and we had like 2x squared plus 7, and then 3x to the third plus 8. Right? We wouldn't really look at the plus 8 or the plus 7. We only care about what's growing. Since the numerator is growing way faster than the denominator, this would be another case where you would either shoot off to negative or positive infinity. Okay, let's move on to number 2. We look at what's growing the fastest, right? Don't care about this -6. Don't care about that. 2x and x growing too slow. So that means this limit is the same thing as the limit as x approaches infinity of 3x squared over 4x to the third. And we can simplify that further. Got the limit as x approaches infinity of 3 over 4x. So now, well, what would happen if I plugged in a really, really large number? Well, we'd be dividing by a really, really big number. So this is going to approach 0. Right, it's going to flatten out. We have a horizontal asymptote at y equals 0. That's case number 2, right? Dividing. If we have a variable in the denominator is growing faster, then we're going to approach 0. Now in this next case, right, we look at what's growing and what's not growing fast enough, right? Don't care about this, don't care about this. Only looking at the leading terms for both the numerator and the denominator. That becomes 2x squared over 3x squared. And that's going to simplify, right? So this limit, we're going to have a horizontal asymptote at y equals 2/3. Right? Negative, positive infinity doesn't matter because no matter what, both the x's are going to cancel and we're just left with the coefficients.